Welcome everyone. So today we'll discuss about electron spin resonance spectroscopy and their questions which are asked in the MH set examination 2023 which is held on 26 March. So electron spin resonance spectroscopy is based on the absorption of what microwave radiations by and sample or material or a molecule having unpaired electron which placed in magnetic field. So according to that electron spin resonance spectroscopy, electron or the paramagnetic substances having the spin motion of an electron, and that spin either plus half or either minus half. When you placed that sample in the magnetic field, so these two spin state, they are lifted and you will get the two spin orientation where one is aligned with the magnetic field and one is opposite to that of what magnetic field. So that del E, that is difference between two energy level, it must be equal to h nu, or we can call as a G beta h. And according to that electron spin resonance spectroscopy, that much amount of microwave radiations from klystron as a source that are absorbed, and there is an promotion of electron from lower level to higher level is going to take place now. And that selection rule according to what, the del ms is equal to plus minus 1. In ESR spectroscopy, you will get the spectrum or the two-dimensional graph with respect to absorption versus what the field strength, and you will get this type of what, the spectrum. Now to get the more accuracy, that spectrum is converted into the first derivative, that is the derivative of absorption is going to be taken here versus what the field strength, and you get the sharp type of the signal, and that is the transition which takes place from lower energy level to higher energy level. So this is the basic principle which has happened in the ESR spectroscopy. Now, and that splitted energy level is further going to interacted with the nuclei present in the sample having magnetic moment is not equal to 0. That phenomena is going to called as a hyperfine splitting or hyperfine interaction. Based on that simple principle, we have the first question. The EPR line predicted for the compound CF2H radical will be, here the I value is mentioned for hydrogen and the fluorine. You know that this line can be calculated with the formula 2Ni plus 1 for a single nucleus and 2Ni plus 1 for the different nuclei. So we have two nucleus, one is a fluorine, one is a hydrogen, while carbon is magnetically inactive. So there are two fluorine atoms are there, so 2 into 2 fluorine atom, I value is given, that is half, so 1 by 2 plus 1, 2 get cancelled, and here this is for 2 fluorine and this is for what, the 1 hydrogen. So 2 into 1 hydrogen into I have value half plus 1. Now just calculate this number. 2 get cancelled, 2 plus 1 3, and 2 get cancelled, 1 plus 1 1 plus 1 2. So 3 into 2 means expected line for this compound should be the 6 lines we are appeared for this one. So that's why the answer for this question should be the A. Now, so the electron which is exist on the carbon, your molecule is here. Okay, first there will be a electron spin resonances happen with that unpaired electron. Then according to that hyperfine interaction, this electron is further interact with the 2 fluorine and 1 hydrogen, which gives the hyperfine structure, and according to that selection rule will be del Mi is equal to 0. So this is the question number 1 which is asked in MHSET 2023. Now we'll move to the another one more question again from the MHSET 2023. Now the question is for the number of EPR lines which are expected or observed for para-dinitrobenzene radical anion. Now what is that benzene radical anion? Generally that benzene radical anion are developed, or the radical anions are developed due to this is the structure of that compound. Okay, excess addition of one electron to the neutral compound will get the radical anion. Now in this compound there are 4 hydrogen atoms are there which going to interact with the electron. So that single electron where n is equal to 1, your spin is equal to plus minus half. Under the influence of what magnetic field they will be splitted, you will get the minus half and plus half. This is called as the electron spin resonance. Okay, now hyperfine interaction will be takes place according to the 2Ni plus 1 formula, 2Ni plus 1. So only one nucleus are present here, all are of single kind, that is all are equivalent. So 2 into 4 hydrogen into I value is half. Okay, I values of the half, particularly for I value is half for the. Okay, there are 2 nucleus are there which are active. They are mentioned 14 nitrogen and hydrogen. So this nitrogen is also active. So that means 2Ni plus 1 for 4 hydrogen, and for 2 nitrogen another you have to equation, that is 2Ni plus 1. So in this way you can solve this equation. Now 2 into 2 nitrogen into I value will be 1 plus 1. So 2 into 2, 4 plus 1, 5. Here will be a 5 lines, and 2 to get cancelled, 4 plus 1, 5. So 5 into 5. So expected line from this compound will be 25 lines will be expected, and that's why your answer will be B now. Now this is called as a hyperfine interaction. So that electron is interacted, or the electron spin. What is hyperfine interaction? Electron spin, that is plus half or minus half, is going to be interacted with the nuclear spin, and this interaction is called as a hyperfine splitting or hyperfine interaction. So in this way you will get the how many 25 lines, particularly for para-dinitrobenzene radical anion. So these are the 2 questions which are asked in this previous the examination which is held on these 2-3 days before. So our okay, so likewise you can solve these questions based on that ESR spectroscopy. So we will again meet you by considering the other example from the spectroscopy in the same paper. Thank you.